Good morning, afternoon, or evening, depending on where you are as you join us for the global launch of this year's first LEGO League mission into orbit. At the end of the show, we're going to have a sneak peek at the Mission Moon Inspires model for LEGO League Junior, or for First LEGO League Junior. I'm your host, DJ Knight, and I'm here with Mike Grenier from First LEGO League, who's going to be our tour guide on today's festivities. I'm also joined by Max and Cy from First LEGO League Team 38, 662, the Astrobots, yes?
Yep. Yes. Astrobots from Bedford, New Hampshire.
Definitely. And I'm excited to see their reaction as to what we're going to cover here very shortly. We are live here at the First Twitch studio in Manchester, New Hampshire, where we broadcast all sorts of exciting First content. If it's your first time here, do yourself a favor, hit the follow button, and get ready for the awesomeness that's going to be coming here soon. For those of you who are unfamiliar with who we are, FIRST stands for Inspiration and Recognition of Science and Technology. And FIRST was founded by inventor Dean Kamen to inspire young people to become interested in science, technology, engineering, and math, otherwise known as STEM. Here at FIRST, there are 4 primary programs for grades K through 12. Today, though, we're kicking off the 2019 First LEGO League season into orbit and the 2019 First LEGO League Junior season, Mission Moon. I'm here with Mike, who works at First LEGO League. Mike, can you tell us a little bit about what you do?
Sure, yeah. So I work here at First headquarters in engineering for First LEGO League and First LEGO League Junior. And so I work alongside another engineer, and I work with 2 designers from LEGO in Denmark. And we actually work on creating the models, rules, and mat for the First LEGO League game, as well as the First LEGO League Junior Inspire model.
All right. That's pretty awesome. I got to say, I'm kind of jealous that you get to work and play with LEGO at work. That's pretty awesome. So, Max and Cy, tell me a little bit about the team that you guys are on.
We're the Astrobots from Bedford, New Hampshire, and for 3 years.
And how many kids are on your team other than you two?
We have currently 5 kids, or 3 other kids, excuse me, on our team right now, and maybe 1 more.
And how long have you two been in First LEGO League?
3 years.
Each?
Yeah, on the same team.
Have you been on the same team the whole time?
Yep.
And I imagine you're from the Lightning Legos originally, right?
Yeah, first team.
Awesome, awesome. So are you planning on going into the other First programs after you get done with LEGO League?
Yes.
Yeah, me too.
Definitely. So are you excited to see the into orbit missions and models?
We are actually really excited.
Very excited.
I can tell Max is excited. He stole the mic. Like, yes, we're excited. So do you have any guesses as to what we're going to see?
I'm just guessing something, maybe landing pad, something with space. I really don't. Those are my only guesses.
What about yourself, Cy?
Something to do with sorting space junk, honestly.
There's nothing wrong with sorting space junk. We are not really set up for space, so there's got to be junk. Can't set down on a disgusting place, right? You got to clean it up. So, Mike, can you tell us a bit about the design process?
Yeah, we work with a pretty extensive lead time, and we work with, well, first, a topic is chosen around a very important or relevant maybe social issue or global issue that's happening right now. And you know, after that topic's been picked, we work with a bunch of topic experts in the field. And so that, for this year, for example, we worked with people from NASA and propulsion engineers and people from planetariums and actually a Danish astronaut named Andreas Mogensen. And a line that was said to me that is very true is we turn them upside down, we shake them for everything they know, and they tell us so much about their specific area, and we kind of take that and we tailor it and try and make it into a mission or a challenge that is then put on the field.
That's awesome. In my head, I just imagine turning an astronaut upside down, shaking him. Give me your data. I need your information. So, Max and Cy, are you guys ready to find out if any of your guesses were correct?
I am.
I'm very excited again.
All right. So, with that, Mike, shall we do the honors?
Let's do it.
All right. So, I'm going to stay over here. So, Mike, please lead in.
Yeah, of course.
No, not yet. You stay here.
You guys ready?
So, 3, 2, 1.
Wow, that's crazy.
There it is.
Nothing what I expected.
Breaking
I was
expectations
really
on a daily
off,
basis.
actually.
Say again?
I was really off.
How so?
It looks a lot cooler than I thought it would.
Yeah, that's great.
Nice. So, we're here with this awesome. You guys check out this awesome clip about this into orbit set.
Main engine start. 4, 3, 2, 1.
Okay, this is kind of amazing. As we pulled it off, I kind of heard Max and Simon over here making some pretty awesome comments about what they were expecting and what's different. So, Mike, would you mind kind of walking us through the
Of
mission?
course. Yeah, absolutely. And, you know, if we start here, first, I think it's really important to mention base. And so looking over here in the corner, if you're not familiar, you are actually building, teams are building robots that are fully autonomous. There's no controllers. And this little quarter circle in the corner here is the only place you're allowed to use your hands. So teams can load their robots there. They can move around models that come in base, like the ones you kind of see here already. They're able to, you know, move those around. So if they want to put their robot somewhere and maybe something's in the way, you can push it out of the way. But then once you press go, the robot has to do everything that's outside of this quarter circle. No hands, no controllers. That's it.
So, a fully automated
Yes.
Lego robot that they have to build and program themselves.
Exactly.
Okay.
Exactly. So to show you an example, like starting here, this is actually to the first mission, and the model itself is called the Space Travel Ramp. And to give a little bit of background, it's about stepwise rocketry. You're sending payloads, you know, one at a time up to another extraterrestrial planet. So in this case, you know, you may want to send a vehicle payload to another planet, so you have a way to kind of move around on that planet. So that's what comes preloaded on this model. And so the robot has to come out of base and on its own activate this model and send it down the ramp. And the objective is just to pass this first track connection, which is highlighted in the rules, which you can find later. But then those mission models I was talking about that start in base, like these two here, can actually be loaded onto the robot in base by hand and then brought out here with the robot loaded, and then you can run it again, send another payload down. And so the two that are remaining are actually a crew payload. So you're sending your guys up there, or your girls, and sending them just to check out the planet. And then you also have a supply payload, because of course you're going to need supplies.
Right. So you have the first dropping a vehicle off, then you bring your crew, and then you bring the supplies, so that once you get to the asteroid, you have the opportunity to do some science.
Exactly.
Or some research.
Exactly.
And it looks like you guys have a question.
Yeah, my question is, what would happen if the vehicle somehow fell off while, like, before even gone on to over this ramp?
Sure. So maybe if you were loading this on over here and it were to fall off, unfortunately, you can try and retrieve it and do it again. The mission itself is to start on the left side of this first track connection and then roll independent just past it. If it were to fall off right here, you'd still get the points for it, because it just needs to pass that.
If it was half over, like right here, if it was like this, would it still count?
And it fell off right here?
Yeah.
So you have to get completely past the first track connection. Great question.
I feel like a good question with that is, what's the significance of this first track section?
It is just a place to point to for
Gotcha.
refs. So they have a place to say, okay, yes, it did, or no, it didn't.
Easy
and then they
point of
can
reference.
score. Exactly.
Gotcha.
Yeah.
So that's a pretty impressive series of things. You got 3 different pieces, starting with the vehicle, then you have your crew, and then you have your supplies that you can also push down the first mission.
Exactly. Exactly. And you can also see I know I haven't talked about this, but tied to it is actually the solar panel here. And what's neat about this is right where I'm standing is, if you're competing, is another field, a mirrored image of this field. And we try and make a shared model. So one that you are actually either working with or possibly against the other team, but you can work together in what we call cooperation. And so you have the ability to talk to the other team. The objective for this mission is a solar panel, and you want to collect sunlight for energy, right? So you tip it towards a direction that would catch the light, and you can tip it towards their field and guarantee yourself points. Or you can talk to the other team and try to align them towards the same field. So that might mean tipping one towards you, or maybe if they're going to tip it towards you, you tip it back towards yourself for more points.
So that's a little different than last year's game.
Yes.
And you seem like you had a question. Max.
Yeah, I remember how last year there was one. It was actually around this spot, and you could pour water to the other side.
Yeah, so that's a great example of a shared mission where, you know, you have the ability to help another team while activating the model, and that is the exact case in the Into Orbit game as well, where you can actually work with the other team, talk to them prior, and try and gain some more points for both of you guys.
I like that rule.
Yeah.
All right, so we've got the first mission down. We've got the solar panel down. What's next?
Sure. So let's talk about the core site here. So this is a core site, and it is about trying to find elements when you're on the planet. So now we've gone across, we've landed on a planet or asteroid in this case, and you are looking for usable elements. So dirt in space is actually called regolith, and that is the first piece that you would pull off here. So this is a regolith core sample. And you also have white, which is your gas. And then you have water and another regolith. And so when astronauts go to space, they're really looking to try and find these elements, because if you are able to find something like ice or water, those can be broken down into their elements of hydrogen and oxygen, and you can actually start making fuel and go to further planets, or just use these elements to your advantage. So that's what we're trying to do here, and they do actually have places elsewhere on the field, which I'll show you guys a little later. But one I can show you right now, because it's right here. We worked with, like I had mentioned, a couple people from NASA, and one of the very cool things that they showed us is they're actually working on taking regolith and trying to make usable building blocks in space to build like homes and stuff like that, in case we were to ever want to live there. So you can take this regolith core sample and put it into a 3D printer, and yes, they are doing that. They are taking regolith and 3D printing, so to speak, usable blocks for building, and that's what you're going to do here. So if you drop it into the 3D printer, out comes a usable block for building, and this will get used as well.
So you were right about your space debris and gathering it up.
That's right. So
we've got the regolith, we've got the gas and water, more regolith, that we can use to 3D print new blocks so that we can build homes in space. What is the next step? So
while we're on this planet, one thing that is very hard is, we had talked about vehicle payloads, but kind of crossing the surfaces can be very hard. You have different amounts force-wise of gravity. On top of that, you've got different textures and stuff on these planets. So crossing and moving around can be a very just difficult challenge. And so we've tried to make it that way here. You can kind of see this model here it's called crater crossing. And you are crossing craters. And so you want to completely cross it. you are bound to fit between these two towers, and you have to flatten the gate completely. So the robot drives, and it has to come from this direction, completely past the gate for you to get points. But you notice it's not symmetrical. There are some differences in the craters, so you really have to build your robot to work with that type of terrain. Expect, like, you know, it's hard, and you just have to kind of build and engineer around that, just like people do in real life. So
you have to build a 4x4 Lego model to kind of go over rough terrain, as you would do if you were on an asteroid or a planet that has a lot of craters on the surface.
Exactly. You could actually almost picture your robot like a robot in space, which is true, or like a rover, and just imagine it like that, and you're trying to cross these craters.
Now, what happens if your robot tips over while it's trying to attempt the crater crossing?
That's a fantastic question. So imagine that does happen, and you get caught here. Well, because it's fully autonomous, you want the robot to go back into base so that you can use your hands again. If it's stuck and you cannot get it back without going and grabbing it physically, we allow you to do that. You can go over and grab your robot and bring it back to base by hand, but you're going to get a penalty. It's known as an interruption penalty, and it will subtract points from your overall score. On top of that, because you didn't completely get past the flattened gate, you wouldn't have gotten the points.
Indeed.
Yes. It also reminds me of one of the missions 2 years ago. The blind man walking the dog. You have to go through a gate.
Exactly. So we try to we want teams to be able to think about the way they build their robot and to overcome these tough obstacles. So that was the case that year, and this year is exactly the same thing. We want you to be able to build your robot to handle different terrains.
Yeah.
Now that's impressive thus far, right? Because we've covered the first mission, which is moving your vehicle over, and then your crew, and then your supplies. We covered the solar panel, which I'd imagine is kind of important when you're on another planet. You kind of want things to be powered.
Yeah.
So I feel like that one kind of explains itself. You've got the regolith, the gas, the water, building new blocks, and being able to build a vehicle that can traverse rough terrain. That's a lot of information just to be held on this part of the field, this close to base. So where do we go from there?
So if we start moving this way on the field, you can actually see a space station. And talking to our experts, they'd given us a lot of insight on, you know, kind of what's going on inside these. And so before talking about what's inside, we really wanted people to understand the outside. And so with this mission, it's actually a big hub. And what you'd want to do is, if someone could pass me that gray cylinder there.
There you go.
Thank you. This is a cylinder, it's called a tube module in the game. And the objective is to insert it into the hub. But it goes beyond that, because you notice there's a couple other hubs here of different shapes. And you need to bring this cone module back to base. And beyond that, for additional points, if you've removed this, you have the option to pull out this dock module and put it where the cone module was. And it's hard. And we know that. And that's why we leave this up to you guys to, and girls and teams everywhere, to just create solutions to these problems. And you may have also noticed on the backside there is a little astronaut hanging on a loop. And so you want to get him back into the habitation hub. And so we gave him the code name Gerhard. A fun little story. He's actually works at Lego Education, and he's been there for many years. And we were able to give him the name Gerhard, where you want to move him to be either partly in or completely in this habitation hub. Yeah. And
I have a question about this.
oh, sure.
When you're switching them, can you take that piece, because I don't want to mess it up?
Yeah, this
Or,
one?
actually, I can just pretend. Imagine
Sure.
this piece was that piece.
Sure.
When you're switching them, does it have to be completely in like this for it to like to count, or can it be like that?
That's a great question. It just has to be like that.
Oh,
So,
okay.
so you can have it like that, and you will still score.
Okay.
That's a great question.
Man, I can just hear
it's-
how much force has to be applied to pull that out. So I'm very interested in seeing how some of the teams are going to handle this. I've seen some teams
Yeah.
with a bunch of different attachments to try to get the robots working. So I'm very curious to see how teams are going to touch that.
Yeah, and beyond that, I mean, we actually put this at an angle too. So not only are you dealing with 3 different shapes, you've got a cylinder or a tube, you've got the dock, which is more of a square, and then you have a cone on top, and then it's spun to be not a perfect angle flush with or parallel to walls. So it's definitely a challenge, definitely.
So Max and Sai, are you guys seeing that as going to be a difficult challenge?
Yeah.
All the challenges are a lot more difficult than last year's.
All right.
Okay, so after we deal with the space station and the 4 missions
Yeah.
that are encompassed within that single space station, what comes next?
So a little cool play on the artwork we did here. You can kind of see this line, and that is actually zooming to the inside of that space station. So now you're looking inside, and these are some of the issues we had talked to Andreas Mogensen, the Danish astronaut we had talked to that I had mentioned previously. He was talking about some of the very real issues they have on the space station, and so we brought you inside to kind of see some of those. And one of the things he had mentioned was, I believe it was about 3 hours a day you have to work out to stop muscle atrophy, which is your muscles just kind of decomposing and kind of weakening and deteriorating to nothing till you're very, very weak. Those 3 hours that you're putting in is just to keep and maintain what you have living life on Earth because of gravity, and you don't have that. So you need to do a lot of resistance style workouts and then cardio. So we actually built that into one machine here where you have a strength bar which has some resistance for the robot to lift up. And then on this side you have cardio where you want to actually push, and you're moving a dial all the way across, and there's colored areas that you want to fit between here. You can kind of see there's some gray and then white and then orange, and you can see there's 2 legs here, so you can kind of speed up the process by running 2. So on top of that, inside this space station we also have here a food growth chamber, and that is something they had mentioned about growing food. It's very hard to do in space, so we wanted to kind of show that it's a real issue, so that when you guys are exploring for your projects, this is a perfect example of, like, we know not everyone lives right next door to NASA or a space station, but here's one that maybe you could talk to a nutritionist or a botanist, someone else that's maybe in your area, a college professor, or these people. It doesn't have to be an astronaut. It doesn't have to be a space station. If this is what you wanted to research, there's other experts out there that can talk to you about this. And for this one, the objective is to actually rotate this from like a dead soil to more fertile to exactly what you want, which is the food growth. But you can overshoot it, and you've killed the plant. So you want to stop it at the exact moment.
That's intriguing. So you've mentioned a couple of different times about projects, but before we do that, you seem like you had a question.
Yeah, it was actually a comment. The whole table, I like how it represents lots in space and like training for space.
Yeah.
I like this one the most, especially.
Oh, that's awesome. Yeah, I love this model because it was exactly from what he was saying. When I had mentioned turning them up, shaking them upside down, this is the shaking of the astronaut here. We shook the astronaut for the knowledge he had, which was exactly this. And we wanted to put it there, and that's why I love it, because it was pulled from his wording. You have a question?
Actually, my question is, if you completely push this thing dead,
Yep.
do you lose all your points for that?
You do.
Okay.
Yeah, that's a great question. Yeah, you do have to stop so that it is on green
Okay.
for the points.
So you've mentioned project multiple times.
Yeah.
Now, for the people who are at home who've never heard of First Lego League, what is the importance of the project in the First Lego League example, and how would that
Fantastic
entail
question.
the points that you're using for these models?
Yeah, no, that's a great question. So beyond the robot game, you actually have two other elements to First Lego League, which are the core values and the project. And core values, you're learning about like your teamwork and how you're working well with others, and it's really about those skills that you've learned along the way. And the project aspect is fascinating because it's your chance to research an area, learn from experts, develop ideas, and actually work on projects to maybe invent or innovate a solution, or just really work in an area that you find relevant or important or just interesting to you for this year in space, and then work with experts, develop that solution, and then have the ability to share it.
Definitely. So that's adding more education on top of already using an educational tool to build a completely autonomous robot.
Exactly.
Impressive. So that's still a lot of things that we've covered, and we're still not done yet.
Yeah.
So,
Oh,
ooh, we had a question from chat.
all right.
Can you overshoot and pull it back out?
Fantastic
points?
question. With the food growth chamber, if you were to overshoot and then pulled it back, we actually score on a end of game visible at the end of the match criteria. So if you were to do that, yes, you would get all the points with that mission.
Nice.
Yeah.
I can already see, imagine teams building like a little piece, just like that goes up and just like pulls it out. All right,
Yeah.
move it back.
Yeah, and I'll give you one really fun piece about this model too while we're here. Remember how I had mentioned way back at the core samples that these have roles on the field? The water can actually be placed on the food growth chamber as if you're watering the plants for more points as well.
So watering the plants from something out in space. You had a question,
Yeah.
Si?
I don't know if you actually mentioned this yet. Could you push these two at the same time?
There's nothing in the rules saying you can't. So
Okay.
our rule is, if it isn't mentioned, it doesn't matter, and you
Okay.
can. That's great thinking.
Thank you.
The wheel's turning in his head on how he's going to build
Yeah.
this already. I like it. So what's our next objective
Yeah.
on the
So
in-orbit board?
I guess if we're going over to this corner here, we have a lander and a lander release. So to give you a little background on landers, if you wanted to actually land on a planet, maybe to study it or get samples off from the site, landing is very difficult. And one thing that you have to do is, a lot of times when you're going to a planet, you'll actually orbit it a few times, moving in, slowing down, and trying to land gracefully on this planet. Because if you hit it too hard, you could damage your lander and just destroy it. So that's kind of the objective of this mission, is to keep the lander intact. So if you activate the model and the lander's released, you'll see that it's actually two pieces. And if you just allow it to fall, it separates. And this is worth no points. You want to keep this intact. So you want to get this intact in this target, or partly outside in this greater northeast planet area here. But not all hope is lost if you did drop it. You can actually collect these two pieces of the element and bring it back to base, as if you're going to maybe recycle, rebuild. So you can bring these parts back. It's not a total loss if you were to break it. but the objective is to keep it intact, just like we do in real life.
So I have a question about that.
Of course.
If it's like this and see these pegs, if they're not completely in there like that,
Yeah.
and it's still somewhat connected, you can see it there, would it count still?
So we have very specific criteria that you'll find in the rules later about the tan pin connection. And the tan pins here have to actually be intact and touching. I believe it's 2 of the holes. And the reason is, if it's like this, like you had shown, that wouldn't count. You would get 0 points, unfortunately. But had it been slightly more intact, you would have gotten the points. Yeah.
Another question: if it is together like it is, can you still bring it back to the base?
Of course. Yeah, if it was intact and you dropped it here and you still wanted to bring it back to base, you most definitely could do that.
Okay.
Yeah.
Now, I imagine the relevancy of keeping it intact is landing something onto a planet. If it breaks in half, then it's no longer usable.
Exactly. Exactly. And that's what we were trying to show here is, we do give more points for keeping it intact. Because of that reason, it's very important that you land intact because you don't want it to break. You don't want it to end up in pieces. But that doesn't mean that you can't reuse it. So we give the option to bring it back. But yeah, keeping it intact is always a good choice if you can.
Now,
Does it have to?
go ahead.
Does it have to land on its feet, or can it like be anywhere? It's still
That's
intact.
a great question. So the rules are just intact.
Okay.
So it doesn't have to land on its feet. It could be on its side. It could be upside down, as long as it's intact.
Okay.
Right.
So what's next?
Yeah. Well, let's talk about this satellite here. Satellites are. There are plenty of satellites, and and you guys you might not even realize it. Many people might not even realize it, that there's satellites all over the place doing many things, including things like GPS and minor things that you don't even realize, including keeping track of weather. And so we have satellites, and I say satellites plural, although you see one here, because there are 2 more in base. And the objective is, this is an orbit ring that it's on, and you want to push it to a outer orbit. And we define outer orbit as the space between these 2 lines. So you want to push it so that it is in or above. So that's the play on words. If you are, could you actually pass me either one of those
Of course.
Satellites? That's perfect, yeah. Thank you.
You're welcome.
We give the option for above scoring. So if you had a satellite way out here, and although it may be hard to see, this antenna from directly above is actually in between those outer orbit lines. That would count as scoring. And you have 3 chances to do that. There's 2 more in base. Kind of like with the crew, supply, and vehicle payloads, you have 3 different satellites to get on or between outer orbit.
So, in the overhead shot, we're talking about this particular
Yes.
piece. So as long as something is here,
Yeah, so
and
this
inside those 2 lines.
long gray antenna here is directly above the space, and as long as something is, for
Trying to look
example,
at something weird on this one, because I feel like the same thing could apply for this.
Yep.
It was like, even if that little tiny piece
Exactly.
is touching inside there.
Yep, that is, you would get the points for that.
Nice.
And again, yeah, you have 3 chances to do that. So even if you missed one, try again.
I imagine the ambitious teams are going to load both of them up. And just take all of these out right now.
It's very true.
So, can you do all 3?
You can do all 3. Yeah. So if you were able to, this one starts here on the field. You could pull this back, then grab those 2 and push them in here, and you could score for all 3 of them. It's 1, 2, or 3, or none. But yes.
And that applies anywhere from here to the other end of that board. So if
Exactly.
they decided to push from here over into the corner and then put the other two right next to it, that would still apply.
Exactly.
Nice.
Yep.
So we got another question from chat.
Yeah, from the landing mission, if it's not intact, can you take it back to base, put it together, and return to the circle?
Oh, so from the landing mission.
That is
Can
a
you-
fantastic question. Purposefully left out, but great that you mentioned
So
it.
for those that didn't hear, the question was, from the lander mission, if it breaks, can you take it back to base, put it back together, and then put it back into the circle?
Yes, and the answer to that is yes, you can. Because it's an end of, visible at the end of the match, like with the food growth chamber, you do have the option to do that. But it's also important, I should have mentioned this earlier, you have 2.5 minutes total time to complete these missions. So this being on the exact opposite corner of base, that
It's a
may take
long
some
trip.
time. Yeah,
It's a long trip.
may take some time, but it may be worth it. If you want these points, you want to come out here and you didn't have it intact, and you want to push it back out, and you've got the time, do it. Do it.
I'm just imagining doing all this in a half an hour, let alone 2.5 minutes. It's absolutely ridiculous. And that's one of the things that excites me about First Lego League, just seeing last year's game for the first time and watching the amount of things that students could do and then watching them do it in
Yeah.
2.5 minutes. So like I'm looking forward to seeing matches where students can knock a lot of this out.
Yeah, and just a fun side note. Every time we sit here and when we're writing the rules, we try and think of every single possible solution that someone could do for these missions, and we're like, we tailor the rules to maybe fit or not fit something that we wanted to happen. And every time, the creativity of children far surpasses anything we can think of. Every time I watch teams come up and solve a mission, and I'm like, no way, you can do that? And like, I'm sitting here looking at our own rules like, what, how did they do that? And it's just fascinating. It's awesome to watch. Yeah.
It's that creativity and not having heard a lot of no. So it's like, no, this is going to happen. Believe it.
That's
So
right.
We've got a lot that we've covered, and we still aren't done.
That's right.
So what is the next step after we talk about the satellites?
Yeah, so if I push these out of the way for a minute, you can actually see here, this is known as a meteoroid catcher. And although it is not 100% accurate to the way it's done in space, meteoroids, in this case, this blue ball is symbolic of a meteoroid. And the objective is to deflect it out of the way so it's not crashing into the Space Center. And so we have a catcher here. And although you may not have a catcher in space, deflection is still nice. You don't want it to crash into you. So we have a meteor that we give the rule you have to be to this, west side, left side of this line here. And you have to hit the ball to travel into one of these areas. And you get points depending on the area that you were to get it into.
Are you allowed to use some sort of arm to drag it there and then put it there, or do you have to hit it?
So that actually goes to this, because you have to stay on this side of the line, you could have an arm, but it has to stop before you get to this line.
Okay.
And another fun little piece is we did give you another meteoroid in base. So you have the option to reload it or take it from base the way it is. So you could have it put back on this ring reset, ball reset, try again. Or start with it there. And the option's up to you. And actually, furthermore, you could actually take the ring, have the ring taken away. If you find that you don't want it there, you have the option with the second ball to take that ring away.
So that's taking the second ball from base, pointing it here, this tiny little ring, and having your robot bring it back to this ring, from base to this ring, and then hit it again.
So for this one, we do allow the refs to reset the ball by hand. So the refs can take it, and you'd want to let, the team would want to let the ref know, hey, we plan to use a second ball. the second meteoroid. So we'll take that. The ref will take that and actually hand place it back on here, and then the teams have the ability to deflect a second one. But the deflection has to be done by the robot, completely autonomous.
Will they then get a penalty for the reset? If they use the second meteoroid?
Because it is written into the rules that it is to be reset by the ref by hand.
Gotcha.
So it's an exception.
And Sai has a question.
Sure.
It looks like.
Could the ball go in the same same meteorite catcher place?
Yes,
as
it
the
can.
other one?
It can.
Okay.
So you can get points for it being in the same or any combination of them. Great question.
Thank you.
Yeah.
Well, they then get extra points if they use the second ball after they got the first one and then got the second as well.
Yeah, if they were able to get both those, they'll definitely get an extra points there. So,
Indeed.
you guys want to see some more missions?
Yeah, sure.
Okay.
It's crazy that we've been here this long and there's more missions.
Yeah, and this model here, I had mentioned we talked to people from a observatory, and we wanted to show a telescope, and that's exactly what this model is. It's a telescope, and we want to point it at, if you could imagine, a constellation, or maybe a planet, or anything. Just if you're looking to target a very specific thing in space, you got to be accurate. So, aiming this is the goal for this and objective for this mission. So you want to turn this model, and like it was done with the exercise machine, you have a kind of like a dial here that you have 3 options: a gray, a white, and an orange, and you get more points for the
further you go on
the
that.
further you go. The difference between that mission and this one, there's no stop to you can go past on this one, which means if you try and aim for this orange and you go a little too far, you could lose your points, which is definitely something. Yeah, it's rough. That's a great way to put it. It's rough.
So with the cardio, this is limited to being at the very edge of this. It can't go past that.
Exactly.
Whereas that one is just like free range. If you overshoot it, you just overshot it.
Exactly.
Gotcha.
When you overshoot it, can you put it back?
Could you pull it back?
Yeah.
Yes. So another great question. Because it's visible at the end of the match criteria, as long as it's in there when that 2.5 minutes end, you would get the points. Yeah.
Do you have a question, Max?
No.
Okay.
So I see a couple different things that we haven't discussed yet.
Yeah.
And I'm very curious to see in the corner.
Yeah.
There's
So
little red spheres or discs.
yeah. So
What are those about?
these little discs here, when I had mentioned earlier the penalties, when you interrupt a robot, maybe it got caught in the crater crossing, like we had discussed earlier. If it gets caught and you grab that robot and you bring it back to base, that's where these come in. One of these are placed into this corner every time.
So can I see one of them?
Of course.
So I've never seen the penalty discs. That's new to me.
Yeah.
Cool.
So you will actually put them into this penalty area here in the corner, and it's a counter for the refs.
Gotcha.
They can then go at the end of the match and go, you have 3 penalties, and they can check that off.
Indeed.
Yeah.
So I feel like we've come down to the wire.
We are down to the wire.
To the very last mission.
Yeah, and
Now, it looks interesting.
it is. So this one is about escape velocity, and it's the title of the mission. So the velocity that you need to break Earth's atmosphere. So many don't know this, but the atmosphere almost acts like a barrier that is actually hard to break through, and it requires a very high velocity to kind of burst through it. Otherwise, gravity is going to pull you back down. If you don't want to be pulled back down, you got to break through it. So we tried to encompass that into a model, and so you have your rocket at the bottom here, And just like you may have seen at a fair, you have this this big lever, and your objective is to actually hit this so it travels all the way to the top and escapes Earth's atmosphere. Otherwise, it'll fall right back down.
That was a powerful tap you just put down. I want people
That's
to
right.
know that that wasn't just like a little tap. That was a powerful.
Yeah, so if you were to come here and just give a light tap, it's
You wanna go try
coming
it?
back down. Yeah,
Sure.
I just want to try
Go for it.
I'll hold the mic for you. Wow, yeah. That's
Yeah.
I'm gonna like put full strength into this now.
Nice. Yeah, so
And that was with him intent on like, all right, I'm gonna barrel down this thing. That's impressive.
yeah, and we know this will be a challenge, and it's up to the teams to figure out and design a way to solve that. So,
So it's gonna be a good year.
yeah,
Yeah.
Like I'm
Awesome.
definitely looking forward to the things that students come up with to kind of knock out some of these challenges. Just with the space station alone, I'm very curious to see how that happens.
Yeah, and again, these models here are great starters for the project. They are ways that you can actually look at them, and any one of them are real things that nothing is perfect. Nothing is really ever perfect. So anything you see here, if you want to use this as a starter for your project, that's what it's here to do. It's not only are you solving the robot game, but it's giving you a place, inspiring you to continue your work.
Do you have a question, Max?
Yeah. Toll table was amazing. My favorite was definitely the
The cardio.
Yeah.
Ah, that's awesome.
Now, you made a valid point. Just a second ago, you said all of these are great starters for the project.
Yeah.
But there's more to this table, though, right?
Yeah, there's a fun little thing we tried to hide into the field here is if you actually look at the mat, there are Easter eggs that we placed in the mat for teams to find. And of course, I can't tell you those, but it'll be up to you to look through the field. You know, if you find you have some time, just look at the mat because we did hide some fun little things for you. And actually, to build on that too, we wanted to give you even more fun. So beyond these missions, later in the season, it won't be part of your competitive season. It won't be in a competition. But for some more fun, we actually create what we call secret missions. And they are 3 additional missions using the same elements that you have here that you can actually solve for fun and just see if you can reach these additional goals.
So, is there some way for teams to keep track of some of the things that they're keeping, like some of the things that they're finishing here on the table or the things that they're looking up for their project?
Yeah, so along the way, when you're going through it, it's actually a great way. Maybe put a check mark next to if you have specific missions that you want to solve. Maybe write them down. Work through, set goals for yourself. Certain missions you want to solve, write them down. When you solve them and you can check that box off, do another one. Keep going. And that's what we wanted to do with these secret missions. When you are going through these missions, we want to give you more and allow you to just keep going. So we give you a few extra, and you want to set a goal for yourself and check that off the list, go ahead and solve them.
Okay.
You have a
Do you have a
question?
question? Sorry.
Actually, no, I don't.
Okay.
Okay.
So,
Very clear.
you've mentioned some secret missions. Is
Yes.
there more to the secret missions? Because I feel like a lot of the things that we've been talking about have been like, okay, that's cool, but there's more to it. Okay, that's cool, but there's more to it. So, is there more to the missions?
Yeah, so the missions themselves, again, they use the same elements, but they're totally different than anything that has been given to you. And we play around with the mission complexities to try and really challenge you additionally on top of what's here to give you some more curveballs. So that's really hidden in there. And it's also, there's more stories hidden to them. So although we've talked about a lot of very important things like landers landing and staying intact, you know, the muscle atrophy and keeping yourself, you know, strong. There are additional lessons that we learned that you will get to learn in these secret missions, the stories, the backgrounds that were also taught to us in these secret missions.
I actually have a question.
Sure.
I think you might have mentioned it. Like, what is this meant for? Is it meant for these? I forgot completely.
Yeah,
So
this square here is actually the placement of this. And the arrows here show you the direction it should be facing. So if you were to put it like this or like this, it would be wrong. You have to face it in the direction of the arrows.
Okay, thank you.
All right.
welcome.
So since we're still talking about the map, there's some fairly sizable black and white lines that are placed throughout
Yeah.
the table. What are those used for?
So we actually give those as options for maybe some sensor use. And we really push for that. We want teams to use their sensors because you know, they can help you be even more accurate and, you know, really achieve your goals. So with this one, we gave a black line with a big white border. So maybe you might want to use a color sensor to maybe detect these lines, and they may just help you solve some of these missions.
Maybe. That's like one of my old teacher moves. Like when I was in school, teachers would always like stomp on the floor, like this might be on the test, like something crazy like that. So like maybe you want to use your sensors.
Maybe.
All right. So that is some very amazing stuff. But now that I feel like it's time to talk a little bit about First Lego League Junior and the upcoming season, Mission Moon. I hear we have something to show about that.
Yes, we do.
Awesome, awesome.
Yeah,
So
let's check it out.
Let us move over.
5, 4,
Gentlemen.
3, 2, 1.
Man, I'm kind of mad. Like the music ended. Like that was pretty nice.
I like
So-
that music.
That video was a little bit of a video about the Inspire set for First Lego League's Mission, First Lego League Junior's Mission Moon. So what
Yes.
is an Inspire set?
So the Inspire set can actually be seen here. The Inspire set is something that teams will receive as well as a engineering notebook and a team meeting guide. And teams will be given this team meeting guide to kind of walk them through maybe a session that they'd want to do with their teams. In the engineering notebooks, the opportunity to learn and really dig deep into the topic. The Inspire set, like you had mentioned, that is this kit here. And it has everything that to get you started for building. You guys want to take a look inside?
Let's
Yeah,
do it.
sure.
All right. So the Inspire set actually includes the Inspire model as well, which was the rocket that you saw a minute ago. And it includes 6 base plates for the 6 members on a team. They are actually able to, each member can have their own base plate and build on that. And they will then have the ability to build the Inspire model, which again was the rocket that you want to focus your moon base. That's the goal for this year. You want to build a moon base around this Inspire model. And so the Inspire model, to see it here for you guys, we have the base here, and then the rocket is actually in two pieces. So if we load the first piece on, you have the ability to put these canisters in, which you will learn about in your engineering notebook as you study. And then you place the top part on here, and from here you have a couple options. You have a WeDo, which is the robot used in First LEGO League Junior, and this is the robot configuration that LEGO likes to call Milo, and cute little guy. If you take a motor run by this intelligent brick, you can hook it up to this and make this autonomous as well. And if you run this, you have the option to run it by hand or with the WeDo, but somewhere in your model you do have to use a, there has to be a mechanized part where the WeDo is incorporated. So if you choose not to use it here, you can use it somewhere else. But you can use it here to run it. And as you can see, as it runs, it spits out the little canisters, which can then be used in your moon base.
All right, that's super impressive.
Yeah.
And I don't know, it excites me that kids, like, what is the beginning age for First LEGO League? Is kindergarten or for First LEGO League Junior?
Yeah, it's 5 through 10.
That is
so
crazy.
I know, and
I'm super jealous.
yeah, they are building autonomous robots at as young as 5 years old.
Okay, so that's super kind of awesome. I'm a little jealous. I think something like the WeDo Kit is a great way to get young kids interested in understanding like the logic behind coding. And that's really what it comes down to. We're still talking about science, technology, engineering, and math. This is just another way of doing it. But that does it for us here today. But before we sign off, we have a special gift for you.
Hi, my name is Alexander Gerst, ESA astronaut on board the International Space Station. From here, traveling in Earth's orbit at 28,000 kilometers an hour, I would like to wish good luck to all First LEGO League Junior and First LEGO League teams around the world. I am very excited that over 55,000 teams from all over the world will explore space during the Mission Moon and Into Orbit season. And I can't wait to hear more about the innovative ideas and solutions you will come up with. Whether it's for the robot game or the project, remember to work as a team, making the best of all the different skills you have, just like we do at the European Space Agency and here on board of the International Space Station. Keep an eye out for a series of interesting videos, which will be posted on the First LEGO League and First LEGO League Junior YouTube channel for over the next few months. They will focus on many different space-related subjects, and they might be a source of inspirations for your research projects. I wish you all the best from the ISS, good luck and have fun.
Okay, that was awesome. Video from an astronaut in the space station. You can even see like the tennis ball flying behind him in 0G. That was sweet. I hope all of you at home had fun joining me and Mike and Cy and Max in exploring this year's models and missions for First LEGO League and First LEGO League Junior. You can watch the full replay of this video right here on twitch.tv/firstinspires, or you can check out some of the clips of it upcoming on YouTube in the next couple of days. Don't forget to follow the channel for all of the First Awesomeness coming to you in the near future, starting with next Tuesday at 7 p.m. Eastern. Thanks so much to Mike, Max, and Cy for coming to hang out with me today. It's been an amazing time. I'm DJ Knight, signing off and wishing you the best and the best luck in the upcoming season.